Hello and welcome to another episode to the AgNext Podcast, where we are always excited to tell you what is next from AgNext. Today we are joined by Dr. Zong Liu, an associate professor and extension specialist from Texas A&M University. Let's get into it. Hello, I'm Pedro Carvalho, an assistant professor here in the Animal Science Department at CSU and with the AgNext team. Today we have a familiar face here as a co-host, Dr. Sara Place. Welcome, Sara. Now you're sitting on the other side of the table,
Yes,
right?
yes, I get to ask some questions this time. But yeah, my name is Sara Place, associate professor here in Animal Sciences and with AgNext. And welcome. Thanks for joining us.
Thank you for the opportunity.
Yes, Dr. Liu, thank you again. We are very excited to record this with you. It's a very interesting topic. I've got some questions about manure lately. So can you just go pretty quick a synopsis of your career, who you are, where did you go to school, and what led you to work in the manure space, I would say?
Yes, thank you. That's a great question. I get this question actually sometimes. I usually joke, I was like, I was manure brainwashed. So, well, I mean, this is some important job, and thank you for having me for this talk. And someone have to do this dirty job, right? So basically what I did actually have a really diverse background for my academic experiences background. I did my undergraduate in material science and engineering. But at the time, I always wanted to go out from the lab more often. I wanted the nature. So actually I studied for my senior project on organic biomass, like those kind of materials. And then I came to United States. Actually, I did my master's on agronomy. Interesting, right? Because actually at the time, it's a really good opportunity. This professor was looking for someone who can do protein analysis in tomato, and perfect. Yes, so that's how I got into my master's in agriculture. And then for my PhD, I was always looking for how I can combine this. My first year was in wastewater, civil environmental management on wastewater treatment. Actually, I was working on some value indicators in wastewater. And then I found this good opportunity. We were waiting for each other. They have this project on manure management and renewable energy. And I basically have everything ready for that. And we were click. So for now, I feel none of my background was wasted. I can use everything. And I still use this example for my students. I was like, you learn everything. You never know when you will use it.
That's pretty. So your material science engineering.
Yes.
Then your master's agronomy, Wisconsin, yes.
Right? My master's was actually at Tennessee State.
Yes. And then you went to Wisconsin
for my PhD.
For a PhD, more in the waste management side, or?
Right. My major was in biosystems engineering. Basically, it's agriculture engineering.
Yeah. Yes. So with that background, that level of expertise, can you kind of give us the 101 on manure management? All things kind of like the high level overview of the key considerations for manure management.
Yes, of course, yes. Thank you. Well, I mean, like you mentioned, it's a big topic. I think I can talk for 2 days or in 1.5 minutes.
Yeah.
So basically, I just gave a seminar. I talk a little bit about that. So for manure, especially for large operations, we will start with manure handling, how we can get the manure collected together. And then we do something really important is manure liquid solid separation. It's really important. We can definitely talk more about it. And of course, we have composting. We have anaerobic digesters and how we can later utilize manure. We can use a manure fiber for bedding, and we can reuse the water for flushing the barn, and we can do land application. So that's a really brief overview.
Yeah. So it kind of varies depending on the type of animals and the housing and all those things. So those are all considerations that we have to have. Huh?
Exactly.
Okay.
That's one of the things that you mentioned is anaerobic digesters. And we were just chatting how this business has grown the past few years and the importance of that. Yeah. And it looks like it's maybe not only California. A lot of times we hear about California, but it seems like has gained some momentum in Texas and where you work as the dairies are growing a lot in Texas as well.
Yeah.
Can you share just a little bit about your experience with anaerobic digesters and how is that becoming part of the dairy business in Texas and how you see the future for that as well?
Yeah, of course. Like you said, yes, digesters have been quite popular in California. And I did my PhD in Wisconsin, and we have a lot of digesters over there years ago even. And in the Northeast, they have a lot of digesters, maybe a smaller scale. But when I came to Texas, I was like, we don't have one. We don't have a single one 80 years ago. We don't have any dairy anaerobic digester. At the time, we have a few hog digesters, more like the covered lagoon, which is actually quite straightforward, but not as efficient as the other. But don't get me wrong, those covered lagoons are really, really good. Depends on what is the condition and what you need. So finally, in Texas, I would say maybe 5 years ago, all of a sudden, we just get a lot of those requests from our farmers, and I get a lot of calls actually from the developers. And our farmers, they want us questions, what do we want to do, and if this is a good opportunity, and if this is good technology, because I'm really into it. So I was like, maybe I'm a little bit biased, but trust me, this is a really good technology, and with those opportunities, the carbon credit and the other different incentives, we will actually get benefit of it. Of course, every technology has its challenges. So when I was talking about this, I of course gave all kinds of aspects. But now, after 5 years, we have those large dairy operations. What we are facing now is new, and we need to do so many things in the marketing, and we want to do permit, and we want to access those environmental impacts and other things. And it changes every year. Some I think I mentioned this. I was super proud. One of our large dairy, they came to me. They told me they built their own pipeline, and they asked me about certain questions. I was like, I'm the first one you guys came to. We feel this connection. So that's the first thing. And then it also gave us opportunities and the challenges. For opportunities is, for example, this one large dairy, they have been running their digester for a couple of years, and they do really well. And they they have a scrubber for this H2S because we don't want that. And then they can actually recycle the sulfur. They asked me how can we use that, so they sent me samples. We have been working with them. This is great. And
no, that's pretty exciting. Yeah. I usually go writing questions.
Yeah.
You mentioned there are three main types of digesters. Is that correct? Can you just go and the big characteristics of each one? How do you differentiate them? And
just maybe even an overview of what is a digester?
What is a digester?
What are we talking about?
Okay.
We're talking about digesters.
Yes.
Yes.
Well, that's an excellent point.
Well, yes, I thought because this is already past our first lecture. Okay.
Yeah.
Now let's go back for the real one. So anaerobic digester just literally is in the anaerobic condition, and then we have microbes.
So oxygen free. Right?
Oxygen free, yes. Sometimes we may give a little bit because at the different stages we want to promote the microbe a little bit, but eventually it's anaerobic condition.
Perfect.
And then those microbes break down those organic material volatile solids. So we produce methane. Basically, that's how this, just in one sentence, this is how it works.
What we want to avoid from the cattle.
Yeah. So we're focused on that from the animal perspective. But so in the manure, you're saying we're actually trying to encourage methane to be produced from the manure in these anaerobic digesters.
Exactly. So actually, perfect question. I love this. This is amazing. So we want to reduce methane, but when we build a digester, we want to increase because we can collect this and we can make biogas. We can actually make this compressed biogas. We can directly send it to pipelines, and then we can also able to use it use it in generators and produce electricity.
So the big picture is collecting the manure from the cows. Put in an anaerobic condition, then collecting the gas from that fermentation and transforming that into energy to be used in the farm or even put in a pipeline to be sent somewhere.
Yes, exactly. Actually, I cannot share all the details because it's their operation, but it's one dairy. They produce this biogas, but they wouldn't use their own biogas. They buy biogas to work on their own dairy because their dairy, if they sell out their biogas, they get more since they have the carbon credit.
That's
yes. So that's why, not only just the energy, the environmental impacts, and also our producers will get some more benefits, so we can make this more sustainable and give them more this kind of passion to work on sustainability.
It's really cool.
One of the questions that I have related to biogas, and I've seen producers who were pretty successful in biogas, in biodigesters. I've seen producers that are pretty successful, and I've seen producers that have had some challenges in making that system effective. Do you have any common points that you see in people who are pretty successful with biodigesters, and what are the points that you've seen to be improved in those farms that they started using, and maybe you go back there and say, no, I don't want to use that again. That's a challenge. Have you seen, is there commonality on those two successful, I don't say fail, but challenge operations?
Yeah. I was, let me share one story first before I forgot. Because, when I was in Wisconsin, I work with a lot of digesters, and we know there are certain issues, especially after the digester. I almost forgot this issue until our Texas dairies finally building digesters, and then just not too long ago, I think a few months ago, they sent me sample a clogging pipeline. They actually built up this mineral called struvite. Usually we don't have it, but after digester, this one builds up more often. They came to me, they were like, hey, Dr. Liu, what can we do with it? I'm like, actually, this is really good fertilizer if we could collect it. But then there are so many things we need to consider, we have to work on. And actually, I'm working on a project that have a patent pending on that. So I was like, my patent will probably cannot use it until 4 years or even more. But for now, we have certain solutions, and they send me samples. We're working on that. So with digester, of course, there are certain things go with it. But how, your question, go back to your questions about that. How we can make this more efficient, or how can we make this better? It's always depends on your operation. For example, if this dairy, they have a sand bedding, we really don't want the sand to get into the digester, because a digester is still, we mimic the animal guts. We don't want them eat too much of the sand, right? So the digester, we need what's get into it, and what kind of investment you want to use. For example, this covered lagoon, it's really, really amazing if you want something low cost, because compared to the other ones, it's cost a lot less. Over my seminar, I think I work with a few of those plug flow digesters. Once they set up about everything, the cost, one is more than $30 million. The other is more than $40 million. Wow. That's a lot, yes.
Yeah.
So
very expensive.
But that one is way more efficient, and they probably can. Are they willing? Are they harvesting not only the biogas? What else are they harvesting? More things to use as the manures or things like that? Can you?
Yeah.
What is what is the pros and cons besides the cost of each of those biodigester systems?
Okay. So all great questions. Yes. So of course the beginning is about the biogas, how much we can produce and how much we can actually get this carbon credit and all the other things we can promote, with the farm. And a lot of those large digesters, actually we have an investor. So most of the time they actually have their company come over, they have their engineers and everything. But still my producer, they were like, we really should introduce you to our company. So because there are certain things they didn't really realize, what's going on the farm and what's over there. And another thing is our farmers have to sign a contract with those companies. So one quick common question I get from our producers, we still want to use our manure. We want to use it as a fertilizer. Can we still use that? I'm like, most of the time, the company, they wouldn't take your manure away unless you have this in your contract. And sometimes they actually have a manager to help you manage your manure. And the thing is, methane is CH4. It's an energy source. It's carbon and hydrogen. So what we want is in the field as fertilizer is nitrogen, phosphorus, and potassium, and those actually stay behind. Actually, even better because the digester break down those molecules, and it will be easier for the plant to uptake. And also because of the temperature, we actually can kill pathogen. I did one study. Anaerobic digester can reduce quite a lot. I can share a lot of data, but anaerobic digester is really good at reducing odor, reducing bacteria, pathogens and quite a lot. So this is a good operation. Yeah.
Great win-win situation for the biogas and making the nutrients that you want from the manure more available to plants, right?
Yeah, that's really neat. So you mentioned, a lot of this, it takes a lot of research, right? So it's a lot of complex, different technical issues you're dealing with. You kind of have to understand the producer and their operation. You mentioned, you have some cool patents and stuff coming out. Are there anything that you can share of fun projects that you've been working on in this space, even beyond the digesters or including that?
Right. Thank you for giving me the opportunity to showcase my work.
Yeah.
So there are so many. Which one should I start, right? Yeah. Let me share one of those. I think this is one of my passion is I have been producing this. I should bring the sample here. It's a manure candy. So I call it a candy. It's actually a really cool, like a granule.
So we're talking edible.
Yes, exactly. But not for a
not
human,
for
for animals.
That's good.
It's for the plant.
Yeah, allied some
Yes, for our
good.
for our baby plants.
Okay.
Yes. Plant M&M, right?
Plant M&Ms. Okay.
Exactly.
All right. Cool.
So I actually got this like a pelletizer or however you call it from a pharmaceutical company. And I make those granules. So manure is actually naturally a slow release fertilizer. And once as a manure engineer, as an agriculture engineer, we engineer it. And we high temperature, pressure and stuff, and we make this like a granule. So the core is actually synthetic fertilizer. And then we have manure outside. With this, actually, based on the temperature, we can control the release. However, I have to admit, it's not perfect. So that's why a few months ago, I was talking with one of my long-term collaborator, one of the company. They have synthetic fertilizer and synthetic polymer and natural polymers. So we may do one more coating around, so we can actually even better control the release of the nutrients. So what we want is we don't want to just put synthetic fertilizer into the field because one big rain event, they can't just leach in or run off. And of course, we want to give our plants what they need. So that's why we want to control. For example, if you grow corn, they probably don't need a lot of nutrients at the beginning. So that's why we want to just engineer it for each different plant baby. At a certain time, whatever they need the nutrients the most. And in this case, actually, we do really good for the environment. We introduce organic matter, and our synthetic fertilizer companies are really happy. They were like, actually, this will make us look even better, and we need to work together.
So it's really cool to combine the organic fertilizer and the synthetic. That's a very unique idea. And is this kind of more for row crops, like you mentioned, for corn and stuff, or is this more like a small scale garden thing, or is this no large scale row crop production that you would be applying this in?
It depends. If it's in Denver, I think we'll
sell well, the M&M branding might do well with gardeners, I'm sure.
Exactly. Yes, and probably we can brand it really well and sell this in the higher price. Please, company, come to us. Yes, but for row crop, because sometimes it's harder to apply fertilizer. Once we have this, our crop getting. So certain instances over there, and one of the reason we want to combine the synthetic fertilizer with manure is good for the environment and good ideas. But of course, there's one more thing. I think you guys all know this really well. In manure, we actually have more phosphorus than nitrogen. So if we apply manure as a phosphorus base, we usually are low in nitrogen. But if we apply manure as a nitrogen base, we always have too much of phosphorus. There are so many regions we have to control it because we don't want have too much of the phosphorus. We can cause so many environmental issues. So in this case, if we apply this best for the environment, we need some synthetic fertilizer, especially in nitrogen. So that's really why cool. This. Thank you.
Yeah, that's neat.
I really appreciate that.
Optimal plant nutrition, right?
Yeah, exactly. We usually talk more about optimal animal nutrition, but that's cool to think about it from the full systems perspective, right?
That's, let's say, feed additives to plants.
That's right. Yes.
It's
totally
it's pretty amazing to see your passion about manure management. I would
brainwashed.
Maybe I understood. In your seminar. I should look at my notes, but you said that your one of your biggest passion is composting, right? We haven't talked a lot about composting so far. Yeah. Can you just, again, maybe give a 101 on composting and things that you can compost, and what is the advantage of composting compared to the other methods of managing manure?
Yes, of course. This is great, and I'm really impressed because when I came today is my first time actually on campus here at CSU. And when I was using bathroom, I saw they have composting post over there, all the waste can go to compost. I'm super impressed. This is amazing. So for composting, it's quite straightforward. Actually, just between my seminar and this podcast, I get so many people ask me about the composting. What shall we do? I see that passion. So it's similar to anaerobic digester, but it's aerobic. And it's honestly just more straightforward and less technology intense. So for a really successful compost, I would say you need a really balanced diet, like nitrogen and carbon ratio. And also we want to have the good moisture. I think I got questions about the moisture, how much or maybe too much. I would say the max, the optimal is always the best. For example, I think I mentioned if you don't mind, like myself, I would just go ahead and grab it and use my hand. Okay. So squeeze it. If you have water dripping, it means you have too much water. In this case, it will be anaerobic condition and it will lead to a composting failure. So, but we don't want it too dry. Often too dry, it will slowly, maybe a little bit composting activity still going, but not optimal. So, and of course, once we have this, we want aeration.
You gave a really nice example. So it's squeezing but not dripping water, right? What you want is to get your hand wet but not dripping water.
Exactly.
Is that correct?
Yes. Thank you for adding to it. Yes, definitely.
That's a rule of thumb that involves your thumb, actually.
Mm-hmm.
Yes.
Definitely. So now we can make it official.
Yes.
Perfect.
And you also mentioned some things about temperature and aeration as well, right?
Yes. When we have all those good elements we meet, and when we have the nitrogen and the carbon ratio, we have the moisture, the good moisture, and we give good aeration. The temperature should rise from just the ambient temperature to 120 to 150, depends on how big your pile is, or if you have a small bin, depends on. Yes.
So the biogas production from anaerobic digestion, that seems straightforward. That's a product that comes out of it. For composting, what are the advantages? Why would one compost over, say, using a digester, or could you even do both on a single dairy, for example?
Okay, so when we do digester, it's a lot more technical focus, and we have to build the facility, and we have to consider moisture, because digester is more like a liquid. Composting can handle a lot more, we do mortality composting, we do manure composting, we do food waste composting. Actually, we can do food waste digester too, but for composting it's just a lot. The threshold is lower, and we can work on that. There are just so many things in my mind. What else I want to share is, I learned so many of different materials we can actually throw in the composting pile. Okay. For example, on campus when I'm in car station, I learned we have a lot of horse manure from our equine facility. Here, you guys are really big with equine, so I'm sure those wood shavings for bedding, they are perfect for composting. And Dr. Mengmangu, she's in the horticulture department, and I learned that they have a lot of materials like a cut flower waste after you did the flower design. What left over there before, we just discard it, and now we can actually use it for composting. And I don't know, I should do this study. I don't know how much of the cotton production here in Colorado, but in Texas, even on campus, we have cotton gin waste. We never use it until I was like, hey, let's do composting, because I have a little facility, not big, I'm still promoting. I'm like, hey, Deans, please let me, maybe they will see this and they will give me more space. We can do more composting. So this is really good. And to speak of mortality composting, actually in my seminar, I did show this large windrow. We have this large animal carcasses, just hand to tail. We have this. So after 6 or 9 months, it's basically everything's gone. And we can actually recycle it, and we can apply this to the field and the whole land. You can do whatever you want. So we don't really claim land or anything. If you have a permit, it depends on which region and what kind of operation permits you may need. That's so many.
Yeah. And is that the way that you often manage? I mean, unfortunately animals die in an operation, right? So is that how would you recommend managing mortality of animals? You mentioned about the poultry example, but what about dairy farmers and feedlots and things like that? Is that how you see managing those dead animals, the composting process and things like that?
Yeah, well, I mean, like, since happens, I want to say the other words, but manure happens. So sometimes we cannot avoid, like, that animal, or big or small, or like, just the routine mortality, or like, big events. So I don't want to say this is my favorite, but I would say composting is the most straightforward and really effective, like, reducing the volume. After actually composting, we can reduce the volume a lot, and we can reduce the odor. Well, like, it depends on how we operate that. And also we can get the temperature raised to really high. So like, between 120 and 150 or even higher, we have to watch it. But, in this case, we actually can inactive a lot of the pathogens. I'm not a microbiologist, but, there are certainly a lot of those benefits over there. And it depends on if, like, in a routine mortality, we can use this back to the land. So mortality is, of course, great, but there are some other options like burial and shallow burial. Shallow burial is basically a combination of composting and burial. And we have incineration. And today, actually, I showed the video about the alkaline hydrolysis.
Yes.
And also, I just got a new grant last fall, all those mortality dehydrator. So we have like a poultry or smaller other animals, and eventually we come out is meat powder. And we have a lot of questions came from our like community and everything, like, what's the odor, what's the nutrient value? Can we just apply this directly to the field? So there are so many things, or emission. So we are going to study all of those. I'm super excited because we just put the slab and we're going to install our machine. So yeah,
that's cool. Yeah.
Thank you.
So kind of in summary, like composting could be any organic material, and really your end product is something you hopefully has no pathogens or very low pathogen load, and you can put it on soil, right? Is kind of the key outcome. Okay.
Exactly. But sometimes I feel still like, I don't want to tell them like no, because, yes. So it's like, safer, I would say.
Okay, yeah. Cool. Mm-hmm. And then you have experience, I mean, so you have this experience of engineering and agronomy and manure management, and then you also have experience or interest in artificial intelligence, right? And machine learning. Yes. So how does that intersect with all the work that you're doing?
Wow. Another 2 hours we just recorded. We want to record it more. So so many things we can do. Let me just share like one of the project I think now I can share is I get recommended for funding for the NSF Career Award right before I.
Congratulations!
That's
great.
Much. Yeah. Yes, right before I submitted, right before I promoted. So that was perfect timing.
That's great.
Yes. So basically we just use like satellite imaging system to monitor farms, because often it's harder for us to like go, especially in Texas. But our farmers, like when we have to do like the manure management, manure analysis, they have to go take sample and they have to send it to the lab, and it take them days. And often when I go take samples, I will have to take my students. I will show them. Although now I go less, but before I go, every time I take samples, because I don't want them fall into the manure pit. I don't want them fall into the lagoon, because either they will quit or they never come out from it.
Both bad outcomes.
It's true, exactly. Yeah. And those places, especially for lagoons, they are big. They are like, acre or 2 or 3. Mm-hmm. So each spot we take sample, usually we will get different readings. Mm. So how can we do that? That's why we come into this like a big data. We will take a lot of samples, and then we use the satellite imaging system, and we actually try to use drones and other things, and we install the sensors.
Very cool.
Yes. So not only for nutrient, but also emissions. So we do like, machine learning, big data, and more AI involved. And actually, I was talking to one of my colleague from the Animal Science Department in Texas. Actually, he's a good friend with, I think, Diego. So we were talking about maybe we were looking at the different sensors we can smell in the barn, and certain of those could be markers, indicate the different animal diseases. Maybe we can work on that. Yes.
Yeah, very cool.
That's pretty cool. Yeah.
Yes, thank you.
So here at AgNext, we work we're focused on sustainability in animal agriculture, right? Sustainable solutions for animal agriculture. And it seems like all of your work also involves sustainability, right? Mm-hmm. We always ask the question, and that's It's not a tricky question. It probably should be a short answer. It's like, how would you define sustainability, and maybe take in consideration the 3 pillars of sustainability: economic, social, and environmental? What is your definition of sustainability?
I think my short answer to that, I would say manure is the connection to this circular bioeconomy. Because before I thought I'm the end of the food chain. Everyone feels like, this is the end of it, and how I dispose it, how I manage it, how I engineer it. But eventually, if we treat the manure the best, it goes back. All goes to the soil and complete this circle. So sometimes I feel like maybe my work is important.
It is.
Absolutely. So that cycling of nutrients, right? It's really important for sustainability.
Yes.
That's awesome.
Thank you.
Well, kind of circling back to the beginning of our conversation, right? So you gave us a kind of a brief overview of how you got to where you are today, but can you expand upon how does your role now provide mentorship, but how did mentorship get you to where you are today in your career in terms of influence of other folks on where you ended up?
Yeah, thank you. Well, sometimes it's like, we were not doing certain things like intentionally, but, we try to set up like a role model. Like myself, I have an extension appointment. So I go to different farms, I give a lot of talks. And like, one time I went to like a really remote a region, actually closer to here than College Station. And this family, they were like, can I have my kid come to your talk next time? Because I want him to go to college and maybe do agriculture and especially maybe some engineering. I was like, this is just something we can actually share with our community. And of course, like, we have kids come over. They never thought about agriculture. They never thought about like, actually this is something cool. They always thought about robotic systems. I'm like, hey, actually, we have robotic system working in our field. We just like, encourage and inspire our next generation. And of course, like, our graduate students, our postdocs, and now they are like, leading in their own field now. So
yeah, that's inspiring. That's awesome.
That's exciting. Yeah. And this goes back, probably I'm going to shrink 3 questions in one.
Wow.
First, like, can you tell us a little bit more about your job as an extensionist? You're really passionate. You're talking about talking to people.
Yeah.
You have a really nice conference coming up this fall, right? And how can people reach out to you if they have additional questions after they listen to our podcast? And so, like, just tell us about the extension, your conference, and if someone has another question that we didn't ask here today, how can they reach out to you?
Okay, wonderful. Yes, of course, I want to promote my conference and my work. But before that, can I take 1 minute promote other things?
Of course.
Because I'm an ag engineer. So we have our society, American Society of Agriculture and Biological Engineering. So we actually have our annual conference, and we do a lot of mortality and animal waste and manure management. So I was their past chair of one of those subcommittee. So this is one of the programs I want to share. And also we have the International Animal Mortality Management Symposium coming up next year. Myself as a chair of the program committee. So we are going to call for abstracts. So this is something. And also we have a real thing. It's real. It's not fake. It's Manure Expo. We have a lot of slogans we cannot post, but it's actually on our shirts.
I love the one about the art.
Yes.
Can you, I don't know if you think manure is an art or a Picasso?
Exactly. Yes. And there are other things I probably wouldn't want to talk here, but
lots of puns.
Yeah. Exactly. We have to laugh about because it's our job, and I feel like it's actually a fun job.
Yes.
So, and of course, many other resources like our colleagues and different places, they have those. And to myself, I have my manure conference coming up. It's real. It's called Texas Manure, and I have my website at texasmanure.org. So I have my own Texas Manure YouTube channel and X, formerly known as Twitter. Yeah. So I have those information over there. We publish a lot of things, and certain things we cannot publish because we have certain things like how we manage that animal. We cannot post on there. But if anyone have some questions, please reach out to me. I should bring my poop emoji because my poop emoji.
The QR code.
Yes, I have all the QR code and all my website on there, and I usually tell people if people give you we take the stress away. So yeah, basically that's it. And of course, like, we work together really well with this team. If people want to reach out to me, maybe they can reach out to you.
Yeah. I really like your YouTube channel. We saw a lot of material that before coming to record, but yes, any other questions, Sarah, that we haven't asked anything?
I think the main thing is thanks so much for sharing all your knowledge and blessing us with this wealth of knowledge about manure. That's excellent.
Thank you so much. I really appreciate this opportunity. I mean, I'm so glad that when I can have people like, sit here and talk manure with me and laugh about it. This is amazing. Thank you so much for this.
You're welcome.
It has been a pleasure, Dr. Liu. We appreciate you taking your time, coming here to Fort Collins in a very cold weather.
Chilly. Not a lot of microbial activity happening today.
No.
It's beautiful here.
Yes.
Thank you, Dr. Liu, for coming to the AgNext Podcast. And thank you to our listeners for joining us for another episode of the AgNext Podcast. Don't forget to follow us on Facebook, X, and LinkedIn. If you have comments, suggestions, feedback, anything to our podcast, please send an email to agnext.colostate.edu, and we'll do our best to answer as soon as we can. Thank you.